Good afternoon, class. So this is Mr. Chan. So just want to go over the pretest analysis for Unit 5. So this one is for Geometry Semester 1, Unit 5, the pretest analysis. So we'll take a look at that. And let me just make sure that this one you guys can see better. So let me just enlarge this. Alright, so for number 1, if you draw all diagonal from one vertex of a regular hexagon, so hexagon that means 6-sided figure, regular that means all 6 sides are equal. And how many triangles do you have? Can you make? So the way to find out the number of triangles you can make, it's using the formula n minus 2. So n, which is the number of sides of a polygon, so it's a 6-sided figure. So 6 minus 2, then that'll be 4. So it's going to be 4 triangles that we can make. So here's another one. If that's a decagon, decagon that means 10-sided figure. Again, regular, the difference of regular, irregular. Regular, that means all sides are equal and all interior angles are equal. So if that's a regular decagon, so that means 10 sides regular, 10 sides equals polygon. So then that means 10 minus 2, then that'll be 8. And regular octagon, so 8 minus 2, 6. So now let's move on to the next one. So which one of the following best describe the formula n minus 2 quantity times 180? So where n is the number of sides. So this formula is quite similar to the one I mentioned about, n minus 2, but this one is n minus 2 times 180. So anytime that you see the formula like this, that means it's used to find the sum of all the interior angle, the sum of all the interior angles of a regular polygon. So C is correct. Again, the way to find out the measure of all the interior angles of a triangle, so that means n minus 2 times 180. And then number 3, so what's the sum of the interior angles of a regular pentagon? So the way to do it, n minus 2 times 180. So it's 5 minus 2, which is 3. 3 times 180, so which is 540. So using the same formula that we talked about for the previous one. And then what's the sum of the interior angles of a regular hexagon? Hexagon, that means it's a 6-sided figure. So 6 minus 2, so 4. 4 times 180, so 720. And then regular heptagon, 8-sided figure. So a minus 2 times 180, so 6 times 180, which is 900. And which one of the following best describe a regular polygon when the sum of its interior angle is 900? So now this one, let's take a look at this. So we need to find out what kind of figure that is. So for this one, we need to go backward to find out the number of sides of a polygon. So we need to figure out what n is. Okay, so let me just do it right here on the Promethean board. So what we got here, so it's 900, that's the sum of all the measure of interior angles. So let's do it this way. Okay, so, and we started off with S equals the quantity of n minus 2 times 180. So n, that's what we need to figure out what that is. So times 180. So the sum of all the interior angles is 900. So 900 divided by 180. So divided by 180 both sides. So this one would be considered 5. So n minus 2 equals 5, so n equals 7. So what we found out here, it's a 7-sided figure. So the prefix of 7, which is what? Hepta. So it's a heptagon. Okay, go back to this one here. And it's a heptagon, so 7-sided figure. And now the next one, so it's quite similar. So you want to set up the equations, and then you want to set the sum equals 1,260. And then you solve for n. So it's a similar situations. And this one too. And now question number 5. So what's the measure of each interior angles of a regular pentagon? So if the problem is asking about the measure of each interior angle, so besides doing that n minus 2, the quantity times 180, But also you need to divide it by n, because you want to find out the measure of each interior angle. Okay, so the way to do it, okay, let me open up the new slide here. So the way that you started with this, okay, so here's the question. So again, we're using this same formula, n minus 2 times 180. But the thing is that in order to find out the measure of each interior angle, whatever the result that you have, you also need to divide it by 180. Divided by n. Okay, so let's find out what this first. So we do know that's a regular pentagon, so the prefix penta, so that means 5 size figure, so n is 5. So 5 minus 2 times 180, so we do have 3 times 180, which is 540. And then 540 divided by n, so divided by 5, because that's a 5 size polygon. So once you divide it, so it's 108 degree. So that means the measure of each interior angle, it's 108 degree. So back to what we have right here. So it's 108 degree. And now for the next two problems, they're quite similar. So using the same structure and find out the measure of the interior angle. And now for number 6, what's the sum of the exterior angles of a regular hexagon? So the way to find out the sum of the exterior angles, it doesn't matter what kind of regular polygon that you have. So as long as that's regular, the measure of all the exterior angle is always 360. So it's always 360 degree. And the reason why that is because once you draw the polygon, so let's say that we do have a hexagon. So if we try to make a circle going through all the vertices here, so they're all considered tangent points. So once you go around the circle, guess what? It's always 360 degree. So the measure of all the exterior angles, so they always consider 360 degree. So exterior angle, that means the angles outside the polygon. Okay, so now let's go back to this one. Okay, so 360, 360 for all the measure of the exterior angles of a regular polygon. And now the next one, number 7. So which of the following best describe a regular polygon when the measure of each exterior angle is 90? So if the measure of the exterior angle is 90, so the way to find out the name of the quadrilateral, so the way to do it is just by setting 90 equals 360 over n. So 360 over n, so that equals 90. So let me just open up the new slide. So 360 over n equals 90, because the measure of all the exterior angles of a regular polygon, it's 360. So 360 divided by n, so in other words, 360 divided by 90, and then solve for n. So n is 4. So it's a quadrilateral, 4 size regular figure. Okay, going back. And then the next one, so 360 divided by 45, 8. So it's octagon. 360 divided by 36, 10. 10 size, decagon. And now number 8. So what's the measure of each exterior angles of a regular nonagon? So regular nonagon. So this one will be 360 divided by 9, which is 40. Regular hexagon, 360 divided by 6, so 60 degree. Okay, so quadrilateral, 360 divided by 4, so it's 90. And which of the following is the characteristic of a parallelogram? So for the parallelogram, so the special feature about the parallelogram, showing that both pairs of opposite sides are parallel. Okay, so once again, let's go through that, a parallelogram. Okay, let me go back to this one. So let's say that we do have a parallelogram. So parallelogram showing that the opposite sides are always congruent, and also they're parallel. So again, opposite side, they're always congruent. and also they're parallel. And also the opposite angle, they must be congruent as well. So let's say that parallelogram A, B, C, and D. So that means angle A is congruent to angle C, because those are the opposite angles. And then angle B is also congruent to angle D. Okay, so again, segment AB is parallel to segments DC, and AB is congruent to segment DC. And also AD is parallel to BC, and AD is congruent to segment BC. And what about the diagonal? Well, actually the diagonal, they're considered congruent as well. And also the diagonal, they bisect each other. Okay, so let's say we do have a point E right here. So that means DE is the same as BE. Then AE is the same as CE. All right. Okay, so now let's go back. Let's go back to this one here. So here's another one, special feature about the parallelogram. So both pair of opposite sides are congruent. The diagonal bisect each other. And which of the following is the length of segment EF, given that figure DEFG is a parallelogram? So if DG is 10, so that means EF is also 10. So that one is quite obvious. Okay, so this one too, opposite sides of the parallelogram, it's always the same as the other. So 12, so that means GF is also 12. Those are quite simple. And what's the measure of angle Z? So opposite angles must be congruent. So this one is 30. That means the opposite angle is also 30 degrees. So basically we can skip all that. They're kind of like the common sense stuff. So what about the consecutive interior angles of a parallelogram? Anytime they deal with the consecutive interior angles of a parallelogram, they're always considered supplementary. Again, supplementary, that means the sum of two angles is 180. So angle D is given, so what's angle A? So subtract 145 from 180, so you'll get 35 degrees. In question 12a, so opposite angle, they're equal, so solve for y. So just set that opposite angle equal to each other. So 66 equals 3y, so y equals 22 degrees, or 22, because that's part of the angle. Consecutive interior, so 4x plus 60 equals 180. And then solve for x, so x would be 30. Okay, so using the properties of parallelogram. And now, which of the following is a valid reason why the quadrilateral shown below is a parallelogram? All pairs of consecutive angles are supplementary. The diagonal bisect each other. 13c, the diagonal bisect each other, so it's quite similar. Excuse me for a second. Let me keep the window closed. Okay, question number 14. So what's the length of segment EC? So EC, which is this one right here. So since we do know that AC is 26, so diagonal bisect each other. So half of 26, which is 13. Okay, so the rest of this is quite similar. So BD is 18, half of it, which is 9. Excuse me. And then the next one, 14C. So AC is 24, so half of it, which is 12. And then question 15. So find the value of x that makes ABCDs a parallelogram. So again, opposite angles are congruents. So we can set that x plus 60 equals x plus 60, but nothing can solve from that. So we need to set the consecutive interior angles equal to 180. So x plus 60 plus 70 equals 180. So solve for x. So x would be 50. So the next one quite similar. So x plus 50 plus 70 equals 180. And then solve for x. So they're quite straightforward. Okay, so I don't see any kind of rigorous, any degree of difficulty here. So 16. So which of the following is the properties of all rectangle? So rectangle, so that's considered one of the special parallelogram. So the diagonals are congruent. Okay. So which of the following is the properties of all rhombus? Rhombi. Okay, so all four sides are congruent. So that's another special parallelogram. Rhombus. And properties of a square, all four sides are congruent, obviously. And what's the length of segment CD given that figure ABCD is a rectangle? Again, BA is 10, that means CD is also 10. So this one is quite straightforward. And then 18, what's the length of BD? Okay, so BD is right here. And given that figure ABCD is a rectangle, so AC is 26. So that means BD is also what? 26. And what's the measure of angle MOP? Given that figure MNOP, it's a rectangle. So here's the measure of angle MOP. So that's 90 degrees. So that means 90 minus 55. So then that'll be what? 35 degrees. Complementary angles. 90 minus 50, 40 degrees. 90 minus 25. This one's 25, the other one's 25. Alternate interior angles. Again, the word problem is pretty similar to the one that we were talking about. So half of the diagonal is 8.1. So that means the whole diagonal is 16.2. 2 feet plus 2 feet, 4 feet. So it's quite straightforward. And which of the following matches a quadrilateral with the characteristic list below? 4 right angles, okay, both pair of opposite sides, parallel and congruent. And all 4 sides not congruent. So not 4 sides are not congruent, so then that'd be a rectangle. So 4 sides are congruent, both pair of opposite sides, parallel, diagonals are perpendicular. So the things that the difference of the square and the rectangle and the rhombus, so those 3 special parallelogram. So for the rhombus, the diagonals, they're always considered perpendicular. And this one showing that all 4 sides are congruent, but both pairs of opposite sides are parallel. So it's a rhombus. So figure has 4 right angles, 4 congruent sides, both pair of opposite sides are parallel. So it's a square. So which of this quadrilateral type must have 4 sides congruent? So it's got to be square and rhombus. And this quadrilateral type must have all 4 angles congruent, 90 degrees. So it's rectangle and square. Rhombus, so that's not the one because that the opposite angles are congruent, but all those 4 angles, they're not congruent. And then 22C, so which of the quadrilateral type have congruent diagonal? So rectangles and square. So given that figure LMNO, okay, so that's a square, and LM is 12, so that means ON is also what? MN is also 12, because all 4 sides are equal. So this one's pretty straightforward. So what's the length of MO? So half of it is 4, so the whole thing is what? 8. Quite straightforward. And trapezoid. So what's the correct term for segment RL? So that's called the altitude or the height. And okay, so for the parallelogram, what's the correct term for segment BE? So that's the height or the parallel of the altitude. So altitude is the same as the height. So what makes the trapezoids and isosceles trapezoids? So the legs must be congruent. Okay, so let's move on. 26. So 26, this one is all about the mid-segments of a trapezoid. So now let's do this problem here. Again, just want to highlight the figure. Copy and paste. Okay, so now what we got right here, so it's a trapezoid. So this one is about the new formula you need to know. So this one is called the mid-segment. So anytime that you deal with the mid-segments of a trapezoid, so QR is the mid-segments of a trapezoid, because that point P is the midpoint of segment MN, and R is the midpoint of segment OP. So mid-segments of a trapezoid, the way to find that is 1/2 times the quantity of the lower base plus the upper base. So the mid-segments, what we got here is 14, so half. Lower base, which is considered 2x plus 6. Upper base, then that's 8. So now we want to solve for x. So 1/2, we can always get rid of the 1/2 first, multiply by 2, so it's 28. So 28, and then the rest of the quantity, combine the like terms. So we do have 2x plus 14. So 28 minus 14, then that's 14. So that goes 2x. So x is 7. Okay, so go back. Yeah, x is 7. Again, mid-segments of a trapezoid. So mid-segment, it's always the same as 1/2 times the quantity of the lower base plus the upper base. Okay, so the rest of this, they're quite similar here. And now 27, what's the value of x, given that figure ADCB is an isosceles trapezoid? So AC, well, we know that it's 3x plus 15, and then BD is 7x minus 9. So basically, we can just set those two diagonal equal to each other, because that's an isosceles trapezoid. Okay, so again, so let me just highlight the figure. Okay, copy and paste. Image. Okay, paste. Here we go. Again, it's hard to read those numbers. And that was a terrible print. So what we found here is 3x plus 15 and then 7x minus 9. So that means the equation is going to be considered 3x plus 15. So you want to set that equals to 3x, 4x minus 9, I think. No, 7x minus 9. 7x minus 9. So solve for x. So subtract 3x both sides. And then add 9. So we do have 24 equals 4x. And then the rest of this divided by 4. So that means x is what? 6. Okay, going back here. And now here's another one, it's trapezoid, so isosceles trapezoid again. So again, if that's an isosceles trapezoid, so that means the bottom and the upper base angle, so once you combine them, it's always considered 180. So the way to solve for x, so you want to set that 3x plus 16, so that plus x, so then equals what, 180? So 3x plus 1x, 4x, plus 16 equals 180. So 180 minus 16, then that would be considered 164 divided by 4. So it's 41. So again, combine these two angles together and set that equal to 180. And then you solve for x. Okay, so now that's it for this pretest. It's pretty straightforward. I think it's one of the easiest unit. Okay, so thank you for watching the video today. So I'll see you guys next time. Take care.